Now live. Question 4. An equilateral triangle which... Now here's the key word here. The key word here is... Equilateral triangle. With each edge equal to 4 centimeters. It's tessellated. Tessellated means tiled. To give the shape below. Okay, put your hands if you got this first question right. Okay, excellent. Right. What is the perimeter of the whole shape? So we know that this one length is equal to what? Is equal to 4. They're all equal to 4, isn't it? Yes. So let's just start from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sides. And each one is 4 centimeters long. This is my calculation. 12 times by 4. And that will give us an answer of 48. So 48 centimeters the length. That goes here. Next we've got to work out the size of angle X. Now I'm not going to move the page down. I'm going to do it here because it's easier. We can actually see the work. Okay, put your hand if you got that one right. Angle X. Okay, right now. The key word is equilateral triangle. In equilateral triangle, all the lengths are the same. So you use a dash over here to indicate the length are the same. And all the angles are the same. What's the angle sum in a triangle? And then you got 3 equal angles, so you divide it by 3. So each angle, so I'm just going to write it here for the moment, in this part of the video. So each angle will be 60 degrees. Excellent. Right, let's move on to the next one. Next question. Okay.
Next question.
The next part of the question. Okay, right. Okay, so what is the size of angle X? So we've done that, was it? So I'm just copying it down here now, just copying it down. How many lines of symmetry does an equilateral triangle have? So if you have an equilateral triangle, so it has 3 equal lengths, so you'll have, the lines of symmetry will be 3 as well. Yeah? So just 3 here, just 1, 3. Next, if 3 of the individual triangles in the shape are to be shaded blue, what percentage of the tessellation would be shaded? If 3 of the individual triangles, let's have a quick look at my original diagram here. Okay. Right, how many triangles do we have? 12. So 3 out of? So you say that they're going to shade in 3 out of the whole shape. So 3 out of 12 right over here. Okay, right, let's have Mr. Okay. Mr. Harun, give me that as a fraction, please. That's a fraction. 3 over, which is same as a quarter. Yes, correct. Now you want to change that fraction into a, this is a percentage.
Yeah, 25%.
Okay, so 3 out of 12. You want to change this into a percentage. We times it by 100. Okay. Can we cancel? Of course we can. Divide. Okay, let's change color quickly. Okay, right. Right, 3 divided by 3 is 1. 12 divided by 3 is 4. Now, so we cancel these 2 by 3. This, now we've got to cancel this diagonal now. So 4 divided by 4 is 100 divided by 4 is. So I'm just working out for you manually. So that'll give you 25%. Or you should actually know that a quarter is a 25. You should know that fact. That makes it quicker rather than us having to do this manual calculation. This is the last resort. Yes? Happy with that? Good. So let's clear this page. Let's move on to the next page. Mass. Good. Dylan. Is it Dylan? Sounds Dylan, sorry. I thought Dylan then. Dylan or give me Dyson. Dylan is playing with the fair spinner below. Keyword here, fair spinner. What is the probability of the spinner landing on a multiple of 3? Now, let's have a look. What does it mean by multiples of 3? Multiples of 3 means the 3 times table. That means 3 or a 6 or a 9. So where's the 3? How many 3 do you have? 1. That's a 9. That's a 6. How many values do you have altogether? 6. And how many of them are multiples of 3? 3. So it's going to be... We've got 3 out of 6, which can be cancelled and simplified down to a half. Okay, that's lovely. Next, what is the probability of the spinner landing on a prime number? Let's just quickly delete some of that stuff on there. We don't want this on here no more. Okay. What's the probability of spinner landing on a prime number? Right. Let's have one of the girls. Right. Let's have Muniba. What does it mean? This word here. We got probability is a keyword, and we got prime number. So prime numbers are what numbers? Prime numbers are numbers like the number 3, and the number. Well done. So the prime numbers are numbers like 2. 2 is not here. 1 is not a prime number, by the way. Yeah. 3 is a prime number. What else here is prime number? So how many prime numbers do we have here? 2. So that'll be 2 divided by 6, which can be simplified into 1/3 by dividing the top and bottom by 2. So 1/3 is the answer over here. Okay, question C. What is the probability of the spinner landing on a cube number? I'm not going to move the page now. I'm just going to do it here. So let's just let's clear that first of all. Hang on a second. Right, let's just change color again. Okay, let's have a look. We need some more colors really. Right, cube numbers are numbers like 1 times by 1 times by 1 is 1. 1 is a cube number. So that's cube number. 2 times by 2 times by 2 is 8. That's a cube number. Are there any more cube numbers there? No. How many cube numbers do we have? 2 out of 6, which is similarly 1 out of 3. The same answer?
Yeah.
Yes. So B and C share the same answer. I'm just going to write it down here. If I can squeeze in here. A third again. That's for answer which one? C. So I'm not moving the page down for the moment, just writing it there. We will copy it down for them, yes? Usman, be happy with that? Iman? Does that make sense? Okay, let's clear this page and move on to the next page. See when you can't give your results, what easy peasy it is. Okay, alright. So the cube number, so what was the cube number answer?
1/3. So he's got to write the color.
It's okay. Because if spun twice, what is the probability that sum of both spinners adds up to 10? If spun twice. Now, you've got to add up to 10. Let's have a look how we do this question. Okay, now, let me turn to the original question here. What is we need to make a small table. We have 1, 3, give me the numbers in order please folks, 6, 7, 8, 9. That's one event. Okay, let's change color now. 1, 3, 6, 7. Oh, never mind. We just use extra space. Doesn't matter. Okay, we're gonna make a small table now, folks. So just bear with me for the moment, please. Right. Okay. There. Okay, don't worry about the writing there for the moment, folks. Okay. Okay, now we need to do a line downwards. What is this called? This is called a possibility space diagram. Possibility spaces. Look at all the different possibilities we can have. Okay. Right, now let's get back to pen mode. Okay, actually this is a highlighter. Now, where can we make what is that? He wants to get an add to get 10. So 1 add 9 will give us here. 8 and what number will give us 10? Oh, that won't work. Okay, what about 3? 3 and
7.
will give you 10. 6 and what number? Can't do that. 7 and
3.
that will give you 10. 8 and no, that won't work. 9 and
1.
okay, now so all these highlighted boxes will give you a total of 10, yes? So how many highlighted boxes do we have?
4.
4.
4 out of 10.
Hang on a second. So we have 4 of them. Okay, out of how many?
10.
Why is it out of 10?
Twice.
Why is it 12? How many boxes do we have altogether?
6.
How many boxes do we have?
1, 2, 3, 4.
1, 2, 3, 4, 5, 6. 6 times by 6 is?
36.
We have 36 different combinations of numbers we can get. 36 possibilities we can get as totals. Okay. Okay, right. Now 4 over 36 so far is correct. So we divide this one by 4, highest common factor. Divide that by 4. So that gives us an answer of 1/9. Okay, so we've got to count the number of boxes altogether. So we didn't have to fill the boxes, we just highlighted them and looked at them. Yeah? So we have 4 chances out of 36 chances. So 1/9 is done. Are you happy with the box, folks?
Yes.
Okay, I'm just going to read this next question. I can see it here. What is the order of rotational symmetry of a regular hexagon? Now, what does those two keywords mean? Okay, let's have Maniba. Regular means that all of the lengths are the same and all the angles are the same. And how many sides does the hexagon have?
Six.
Six sides. So how many, what's the action for order of rotation symmetry will it have? It will also have six. The number of, okay? That's done.
Is there a break now?
Yeah, we'll have a break, inshallah. Let's stop this video.